Zero order reactions. In this video, we will see about zero order chemical reactions. Zero order reactions are the reactions, chemical reactions in which rate of reaction is proportional to zero power of concentration of the reactants are called zero order reactions. The reactions in which rate of reaction is proportional to the zero power of the concentration of the reactants are called zero order reactions. The reactions in which rate of reaction is proportional to zero power of concentration of zero power of concentration of reactants are called zero order reactions. I'm repeating here. If the reaction in which rate of reaction is proportional to the directly proportional to the zero power of concentration of reactants are called zero order reactions. Here reactants are converted into the products at a time when time is equal to zero time. The concentration of the reactants is called as R naught and the product is zero at time t. The concentration of the reactant is taken as R. Concentration of the product is taken as V. From the definition, the reaction rate indicated by minus dr by dt is directly proportional to the concentration of the reactants. Okay, here minus dr by dt represent the rate of the reaction directly proportional to the concentration power 0. Here rate of reaction is proportional to the zero power of the concentration of the reactant. R means reactant. Here remove the proportionality and put the constant called K minus dr by dt equal to K into R power 0. Here R power 0 is nothing but 1. So therefore R power 0 become 1. K into 1 means K only. Minus dr by dt equal to K is equal to K. Cross multiply K into dt means K dt minus dr is equal to K dt. Therefore, in next step we can write that minus dr is equal to K dt. Multiply with minus 1 in both sides. Okay, minus quantity become a plus and plus quantity become a minus. Here dr is equal to minus K into dt. Okay, this next step. Integrate this equation in both sides. Integration dr equal to minus K into integration dt. Here integration dr is equal to minus K into dt. In next step here integration, there is a formula integration x power n into dx is equal to general formula is equal to x power n plus 1 by n plus 1 Okay, here this expression, in this expression we can write integration dr means we can write r power 0 into dr equal to minus k into d power dt. We can write here r power 0 is nothing but 1. 1 into dr means dr itself, integration dr itself. Similarly here also t power 0 is nothing but 1. 1 into dt means dt, integration dt. So this expression, in this expression if you write integration r power 0 into dr, here in the place of x r is there, in the place of n, in the place of x r is there, in the place of n 0 is there. Apply in this formula. Here in the place of x r is there, r power 0 plus 1 divided by 0 plus 1. Okay, simplify it. This become a r power 0 plus 1 means 0 plus 1 means 1. R power 1 means 1 only. 1 divided by 1 means r. R divided by 1 means r only. Therefore, integration r power dr is equal to r. Okay, substitute this data in the place of r power dr is nothing but r. Similarly, integration t power dt means t, k into t place high. Whenever we are doing integration, we have to put the constant called as integration constant. Okay, this expression become a equation 1. Take it as equation 1. When time is equal to t is equal to 0, r become a r naught. When time is equal to 0, r become a r naught. In this expression, we have seen that initial concentration of reactant is r naught. Here, substitute in this equation, in the place of r, take the r naught equal to minus k into time we have taken as 0 plus I. Okay, simplify this expression. Here k into 0 means k only. Here r naught equal to I equation 2. Assume it as equation 2. Substitute equation 2 I value. Substitute the high value in this expression. In the place of high, write the r naught. Here what is there? R is equal to minus kt plus in the place of in the place of high value simply write r naught. Okay, then in next step transpose this r naught to this side, then we will get r minus r naught, r minus r naught equal to minus kt. Multiply with minus 1 in both sides in this expression. Multiply with minus 1 in both sides, so the plus quantity become a minus and minus quantity become a plus. Therefore r naught minus r equal to, here r naught is minus, then it become a plus. R is plus quantity, then it become a minus quantity. Minus kt become a plus kt. Then in next step transpose the t to this side. Here it is k and t. T is multiplying. If it is comes to this side, left hand side, it divides. Therefore k is equal to r naught minus r divided by t. Okay, this is the integrated rate equation of first order reaction. In this expression, k is called as rate constant. K is rate constant. T is the time of reactants. R naught is initial concentration of reactants. R is the concentration at time t. I'm revising from the beginning. Zero order reactions. Zero order reactions are the chemical reactions in which rate of the reaction is proportional to the zero power of the concentration of the reactants. The reactions in which rate of the reaction is proportional to the zero power of the concentration of the reactants are called as zero order reactions. Once again I am repeating, the reactions in which rate of the reaction is proportional to the zero power of the concentration of the reactants are called zero order reactions. Consider an equation, a hypothetical reaction in which reactants are converted to R is reactants, P is product. At a time t is equal to 0, concentration of the reactant is denoted as R naught, and product immediately product R naught formation takes place. So product is 0. At a time t, reactants concentration is taken as R, products concentration is taken as P. Then rate is directly proportional to the zero power of the concentration of the reactants. Here minus dr by dt represent the rate, R represent the concentration of the reactants. Power 0 means zero order reactions. So next step, remove the proportionality and put the constant called as k. Then minus dr by dt is equal to here minus dr by dt minus dr by dt equal to k into r power 0. Here r power 0 is nothing but 1. Therefore we can write that minus dr by dt equal to k. Okay, in this expression cross multiply. In this next step, cross multiply k into dt means k dt. Minus dr is equal k dt. Okay, multiply with minus 1 in both sides. So we will get dr is equal to minus k dt. Plus quantity become a minus, quantity become plus, plus quantity become a minus. Here integrate this expression in both sides. So integration dr equal to minus k dt. Okay, then in next step apply the formula, mathematical formula. Here integration x power n dx is equal to x power n plus 1. Okay, here in this expression integration dr is equal to minus k dt. This expression we can write in this form. Here dr is nothing but 1 dr. 1 we can write in this form. R power 0 means 1 only. R power 0 means 1 only. R power 0 into dr equal to minus k. Here dt we can write in this form, t power 0 into t dt. T power 0 into dt. Okay, apply this formula for this expression. R power 0 into dr equal to R power 0 plus 1 divided by 0 plus 1. Simplify it become a R. Integration dr is nothing but R. Similarly integration dt is nothing but a t. Integration dt is nothing but a t. So this expression become a R equal to minus kt plus I. I is the integration constant. Whenever time t is equal to 0, then concentration of the reactant is nothing but taken as R naught. Okay, simplify this data in this expression. Okay, R naught in the place of R we can consider as R naught. In the place of T we can take it as 0. And why? Because in the beginning the concentration time in the beginning of the reaction time is taken as 0. Then I as it is, write the high value, as it is. Then simplify it, expression become a R naught equal to I. Then assume it equation 1. Here substitute the high value in this expression. Here in the place of I, what shall we write? R naught. In the place of E written as R naught. R is equal to minus KT plus R naught. Transpose R naught to this side, left hand side, then become a minus. Then here minus quantity become a plus. No. Transpose R naught to this side, then it become a minus R naught. In next step, multiply with minus 1. In this step, multiply with minus 1 in both sides. Then transpose the t to this side, left hand side. Then t will goes into the denominator. Okay, this is the integrated rate expression for zero order reactions. Example for zero order reactions are enzymatic reactions, enzymatic reactions. Next to photochemical reactions, photochemical reactions. Next one is under photochemical reactions, example hydrogen plus chlorine gives H2 2HCl. Next one is decomposition of Hi on gold surface, H2 plus Hi2. Thermal decomposition of Hi on gold surface. Next one is decomposition of gaseous ammonia on platinum surface at 1130 Kelvin. Decomposition of gaseous ammonia on platinum surface to form a nitrogen and nitrogen.